Alright, ladies and gentlemen, we are going to do 4.1 today. It is the quadratic functions in, there we go, spelled it right, in standard form. We've talked about quadratics a little bit already. The standard equation, sorry I don't seem to be able to write, is going to be y is equal to ax squared plus bx plus c. And if you'll remember, the parent function is going to be y is equal to x squared. And that is a parabola that's pointing up with its vertex at the origin. So we're going to spend some time talking about the characteristics and how they change. This particular graph, the parent function's vertex, which is right here, is at the origin, and its coordinates would be 0, 0. And the axis of symmetry, I'll put that over here, the axis of symmetry is going to be right here on the y-axis. So that means that it creates a mirror image of one side of the parabola. Alright, so the axis of symmetry is right smack in the middle of a parabola. It goes through the vertex, and it often has an equation such as, so an equation for your vertex is usually going to be x is equal to, and then it's going to be a constant. So it's a vertical line, and it's going to be x is equal to a constant. All right. Let's see if we can get in a little bit closer. Okay, so if I want to graph my function, the first thing that we're going to talk about is a. So if I have my parent function, y is equal to x squared, and I add an a. I know that a is either the vertical stretch, we've talked about transformations before, or it's going to be a vertical shrink. So if a is greater than 1, then it is a stretch, and if a is less than 1 but greater than 0, then it's a shrink. So this would be if a is a fraction, then it would be a vertical shrink. Another thing that a does for us, if a is greater than 0, which means that a is positive, then that means that our parabola is going to open up. If a is less than 0, which means it's negative, then that means that the parabola is going to be flipped or reflected across the x-axis, so it's going to point down. All right? So that's our basic information and what a controls. So a controls your vertical stretch or your vertical shrink, depending on the value of a. And then if a is positive, it makes the graph go up. And if a is negative, it makes your parabola go down. So let's do an example by hand. So this will be our first example. So this is example 1. I want you to graph y is equal to 2x squared. We're going to do it by hand. I'm not going to show you how to do this in your calculators yet. And I want you to describe the transformation. Get that word in there. There's transformation, or potentially more than one. And then from the parent function, y is equal to x squared. To be able to graph well, sorry, technical difficulties. To be able to graph well, I want to look at my a first. I know that a is positive, which means it's going to be going up. I don't have any translations, so I have no H or K, and we talked about those in our last chapter, which means that the vertex is going to be at the origin. Okay, so I can already sketch my graph, and I know that its vertex is going to be at the origin. I know that if A is equal to 2 and 2 is greater than 1, that means that it is a vertical stretch. So the easiest way to get an accurate graph is to pick a point on either the right or left hand side. So I'm going to add a couple of values. So this would be 3. This is a negative 3. I'm going to pick a value, run it through the equation, or run it through my original function, and then plot that value. So I'm going to let x equal, let's do 2. So if x is 2 and I just picked a value on either side of the vertex, then I need to find the corresponding y value. So y is going to equal 2. Here's the x that we chose, and we chose a 2, so I'm going to put in a 2 squared. So that's 2 squared is 4, and then I have 8. So then my point becomes 2, 8. All right? So if I graph that point, 1, 2, 3, 4, 5, 6, 7, 8, I didn't go up quite high enough. We'll put that as an 8. So there's my 2, and there's an 8, and there's the right-hand side of the parabola. Since the parabola is centered at the origin, that means that the axis of symmetry is also the y-axis, which means it's going to be this point 2, 8 is going to reflect across, so I could actually also have a negative 2, 8, and there would be the other side of my parabola with a very accurate graph, except for my yucky little scale. So when you're doing it on graph paper, it will turn out very nicely. All right? Again, you can't just sketch the curve. You're always going to have to graph at least one point. Okay? Let's do another example. So this will be example 2. And in case you're wondering, I'm sitting at my kitchen counter. Sorry, I guess you can't see. And that's why the background is green. All right, for this one, I want you to graph y is equal to a negative 1/2 x squared plus 3. I want you to describe the transformations. We did this in our last chapter, so we want to do it again just because it's good practice. All right, and then we will get an accurate graph. So if I start looking at my parabola, I know that it has the negative, I'll circle it so it doesn't look like I made a weird line, means that it is reflected across the x-axis, which another way of stating that is that the graph is going to be turned upside down. Okay? The 1/2 means that it is a vertical shrink of a half, which means that the graph is going to get fatter and flatter. Okay? All right. The 3 means that the graph has been shifted up 3, and this is going to affect the vertex. So the vertex is going to have an x value of 0 and then a y value of 3. So it is going to take my basic graph like this, and it's going to translate it up 3, and then we'll manage the reflections and such. Okay? All right, so I'm going to go ahead and sketch my graph to get started because I know where the vertex is. So I'm going to do a 3. So that is going to be, I'm going to draw an arrow so you can see it. That's my vertex, okay? And the coordinates of that are 0, 3. then what I'm going to do is I'm going to choose a point. I know that the graph has been turned upside down because it was reflected across the x-axis. Okay, so I am going to choose a point on my x-axis. I don't want to choose a point too far away because then the numbers get big. So I'm going to let x equal a positive 2. Okay, and if I do that, now I need to run it through the function. So I'm going to run that value through the function. And if I do that, one of the ways that I can write it is like that. This means that I am going to take a 2 and run it through this function. And so it's going to be a negative 1/2. I'm going to substitute in the 2 for the x and then plus 3. If I simplify that math, I get a negative 1/2 times 4 plus 3. Simplify again and I get a negative 4 over 2 plus 3. This is a negative 2 plus 3, and so then I get 1. So that means my point that I want to plug into my graph is going to be 2 and 1. This is the y value. The y value is the output. That would be 1. So then if I go to my graph and I go to 2 and 1, I can plot that point. Okay, so there's the 2. Because the graph has not been translated to the right or to the left, the vertex is still on the y-axis. That means that the y-axis is the axis of symmetry, which means the graph folds in half. So I could actually go to a negative 2 and go up to 1 and get the same value. So now I have 2 points plus the vertex. The 3 points help me define or draw a nice curve. And then if I connect those points, there's the left-hand side, here's the right-hand side, and that would be my graph of a negative 1/2 x squared plus 3. All right. So now what I would like you to do is I would like to show you your problem or your task. So I'm going to draw a curvy line, which means this is the problem that you are going to do that you will turn in when you walk in tomorrow. So this is problem number 1. I'm going to give you the problem, and I would like you to pause the graph, look at what I've done, look at the equation, write your work on another sheet of paper, show all of the relevant steps, and then you will have 3 problems, I believe, that you will turn in right when you walk in the door tomorrow. All right? So your first problem says to graph by hand, not in our graphers yet, y is equal to a negative 4x squared. Okay? And that is your first problem. So you need to pause, do this on another sheet of paper, write your name on the top, and this would be the 4.1 homework, and then you'll turn it in tomorrow. So now, while you guys are working, I will give you the solutions tomorrow. Sorry, my dog is barking in the background. All right, so now I'm going to keep going. You pause, do that problem, and then you can pick up when you're done. All right, so the key concepts that we have talked about so far is that a quadratic functions graph, the standard equation is y is equal to ax squared plus bx plus c. We know that that is a parabola. Sorry. So in general, if this were my little baby graph, it's going to look like that until we translate it, reflect it, stretch it, or shrink it. Then we had some characteristics. Okay. If a is greater than 0, which means that it is positive, then we know that my parabola, so if this is my little graph again, is going to open up. if a is less than 0, which means it's negative, then I know, if I draw my little graph, that x is going to be reflected and it's going to point down. All right. Another couple of our characteristics is if a is greater than 1, that means that it is a vertical, see, stretch, which means that the original parabola gets taller and skinnier. Ginger. If a is less than 1 and greater than 0, so that means it's a fraction or a decimal, then that means that it is a vertical shrink, and it means that it's going to get fatter and flatter. So that means that the curve is going to kind of flatten out. All right. Now I'm going to introduce a new little formula. The ones that we've been doing so far have an axis of symmetry. Remember, that's where if you folded it in half, the graph would be the mirror image on either side. But now if we move things, if we translate the parabola right or left, the axis of symmetry is going to move. And so I can find the new axis of symmetry by this handy dandy little formula. So I get x is equal to a negative b over 2a. The b and the a come from my equation. So if I have ax squared plus bx plus c, the variables b and a come from this original equation. So I would take those values, substitute it into this equation, and then I would know the axis of symmetry. Because the vertex of the parabola is always on, the vertex of the parabola is always on your axis of symmetry, I can now find the coordinates of the new vertex. So now I can find the coordinates of the new vertex, because many of our graphs will be translated. So then I'm going to basically use the same formula. I know that x is going to equal a negative b over 2a, and I know that y is going to equal f of that x that I just found. So I would find this value, and once I have a number for it, then I'm going to substitute it into the function, and then I'll be able to come up with a y value, and then my vertex will have coordinates with the x and the y that I just found. Okay? So my vertex is going to have coordinates with x and y. All right? My y-intercept, which is very polite, comes from the original equation. So if I had y is equal to ax squared plus bx plus c, the y-intercept comes from the original equation. So the c in the original equation is the y-intercept. That doesn't mean that the vertex is there. My parabola could be situated off to the right a little bit. This would be the vertex. This would be its axis of symmetry. And then the y-intercept would be right there where the graph crosses the y-axis. So this would actually be your y-intercept. Okay? All right, so let's do an example with our new information. Okay? All right, so we're going to do example number 3. Sorry, you couldn't see that. So we're going to do example 3. Okay, so this is our third example. I want you to graph y is equal to 2x squared minus 8x plus 6, and of course we're still doing all of these by hand. Okay, and then I want you to tell me what the new vertex is, and I want to know what the axis of symmetry is. Sometimes we call the axis of symmetry the axis, and we just abbreviate it as the axis. So I'm going to start evaluating my function. I know that a is equal to 2, b is a -8, and c is 6. Because a is positive, I know that my parabola is going to go up. And then I know that my y-intercept is going to be 0, 6. Okay, so that's a lot of information to gather just from the equation. Okay, so now I'm going to find my vertex by using the formula x is equal to a -b over 2a. And I'm going to substitute my values in. My b is a -8, so I'm going to have a -8. Then I'm going to have a 2, and my a was 2. So this is b, this is a. I'm going to simplify that math, and that's going to give me a +8, because 2 negatives makes a positive, over 4. And when I simplify that, I get 2. So I know that the x value of the vertex is 2. Okay? All right. Oh, that's so much better. So now what I need to do is take that 2 and run it through the function. So I'm going to do y is equal to f of 2. I'm going to run this through this function. So it's going to be 2 times the 2 that we found squared minus 8 times 2 plus 6. And I'm kind of running out of space. So this is 2 times 4 minus 16 plus 6. And when I simplify that math, I get a -2. Okay? All right, and let me turn the page. So I know from the math that we've done, whew, that was weird. I know from the math that we've done, sorry, let me get my page straight, that my x was 2 and my y was a -2. So that means that my vertex of the parabola is going to be 2, -2. And I'll go ahead and rewrite everything so we're on this page. I know that my y-intercept was 0, 6. And then my equation was y is equal to 2x squared minus 8x plus 6. So this is all of the information that we have. So now let's put what we know on our graph. Okay? So I know that at 0, 6, so 1, 2, 3, 4, 5, 6, this is 6. There's my y-intercept. I know my vertex is at 2, -2. So there's 2, here's the -2, there's my vertex. Okay? I actually know that my axis is going to be x is, oops, you can't see that, sorry. X is equal to 2, okay? Because it goes through the axis, sorry, it goes through the vertex. So I'm just going to sketch that. I'll use a different colored pen just so we can see it. It's really not a dashed line, it's a solid line, but just so we can see it. So this is my axis of symmetry. This is x is 2. And I already know how to be able to do the left-hand side of the curve. We knew it went up, so there's the left-hand side. So it goes through that point. I missed a little bit. So that was, if I go over 2 units right here, there's the mirror image. So it was 2 units away from here, so that means it's 2 units away on this side also. And then I can draw the right-hand side of my curve, and now I have a very nice graph. Not really, but you get the general idea. All right, so that was how we graphed that particular parabola. So now we're coming to the time when you would pause the video again, and you're going to do your second problem. So this is problem number 2. Again, you're going to do this on that sheet that you will turn in to me in the morning. Okay, pull this up just a little bit. All right, so I want you to graph, and I want you to graph y is equal to 2x squared plus 6x plus 3. I want you to identify the axis. I want you to identify the vertex, and I want you to identify the y-intercept. Okay. Remember that the axis is an equation, so when you're done doing your math, it will say x is equal to something. The vertex is an ordered pair because it is the vertex of a parabola, and then the y-intercept is also going to be an ordered pair. Okay, so that's how your answer should appear, and then you'll have a nice accurate graph of your parabola. So pause your video, do problem number 2, and then we will check your answers when you come to class tomorrow. All right, so as we move along, the next key concept is really talking about A. A has a significant effect on your graph. So if A is greater than 0, I know then that my parabola points up. And if A is less than 0, which means it's negative, then I know that my parabola points down. Okay? All right. So if we look at these two parabolas, I also know an additional piece of information. The vertex of this parabola is actually a minimum value for that parabola, which means this parabola will never go below this point. So this is called a minimum value. So if A is positive, the parabola points up, then the vertex is going to represent what's called a minimum value. Later, we'll call it an absolute minimum because it never goes below that point. So then over here on this graph, if A is negative, which means that the parabola is turned down, then the vertex becomes a maximum value, which means the graph is never going to have y values that are above this point. They're always going to be below that point. So it is a maximum value, and later we would call it an absolute maximum because there's no point on the graph that's higher than that point. Okay? All right, so now let's see an example of this. Okay? So here's example number 4. All right. As we cruise along, I want you to tell whether y is equal to 3x squared minus 18x plus 20 is a minimum or a maximum of the parabola. And then I want you to find the value of the max or min. Alright, so you've been given an equation. Y is equal to 3x squared minus 18x plus 20. I want you to tell me if it's a minimum or a maximum, and then we want to find the value of that max or min. So basically what this piece right here means is you need to find the coordinates of the vertex. Alright, so basically what this particular set of instructions states is that you need to find the coordinates of the vertex. Okay, so I'm going to turn the page. Oops, new page. Alright, so here's our new page, and our equation that we were managing was y is equal to 3x squared minus 18x plus 20. I know that the A is equal to 3. A is positive, which means that the parabola is going to point up, which means that the vertex is going to be a minimum. So the vertex is going to be a minimum. And now I need to find the value. So to find the value, I'm going to use my formula. X is equal to a negative b over 2a, and y is equal to f of x. Okay? So if I substitute my values into this equation, I get x is equal to a negative 18, b is a negative 18, and then here's the 2, and our a value is 3. If I simplify that, that becomes a positive 18 over 6, and 18 divided by 6 is 3. Now this is my x value of the vertex, and I'm going to substitute that back into our function. Okay? So then my f of 3 is going to become 3. I substitute this in for the x's, times 3 squared minus 18 times 3 plus 20. If I simplify, I'm going to get 3 times 9 minus 18 times 3 is 54, it's negative, plus 20. And then if I simplify, I'm going to get 27 minus 54 plus 20, and then I get a negative 27 plus 20, and so I get a negative 7. Okay? So now all of the information that I needed, I know that the vertex is a minimum, and I know that the vertex has coordinates of 3, negative 7. And then I would have answered the questions that were asked. Okay? All right, let's do another example. So this is going to be example number 5. And it says the same thing. So I want to tell whether the function has a minimum or a maximum. Oops, forgot the m. Okay, and then I want to find that value. So then find the value. Okay, my equation is going to be f of x, which is the same thing as a y. It's another way of showing a y, is equal to a negative 3x squared plus 18x minus 5. Okay. So let's talk about a. I know that a is a negative 3, which tells me that my parabola points down like that, which means that the vertex is going to be a maximum. Okay? So now what I need to do is find the coordinates of my maximum point. And to do that, I have to find the coordinates of the vertex. So I'm going to use my handy dandy formula. X is equal to a negative b over 2a, and I'm going to substitute the values in. So this is going to be a negative, here's my b value, which is 18, over 2 times a negative 3, this is a. If I simplify, I get a negative 18 over a negative 6, which is a positive 3. Okay? Now I'm going to substitute this into the equation to find the y value. So y is going to equal substituting the 3 into the equation. So it's going to be a negative 3 times 3 squared plus 18 times 3 minus 5. Very similar numbers to our last problem. So this is a negative 3 times 9 plus 54 minus 5. So a negative 27 plus 54 minus 5. And I'm going to continue right here since we're almost done on this page. And I'm going to get, if I do this math, a positive 27 minus 5, and I'm going to get a positive 22. And then I'm going to write my answer up here. So my vertex is going to be 3, 22, and it is a maximum. And that would be the answer for that particular problem. Okay? All right, so if we turn the page, feel like it's story time. If we turn the page, you're going to pause and you're going to do your last problem. So this is problem number 3. You're going to need to pause and you're going to answer this question on your homework. When you walk in tomorrow, you will turn in all 3 problems, then we will go over questions, and then you will do some classwork, which will be due at the end of class. So here's your 3rd problem. So remember, once I get it up, you're going to want to pause and do the work. So this one wants you to find the value of the minimum or the maximum for maximum value, sorry, I forgot a word, for our equation of y is equal to 4x squared plus 16x minus 3. So I want you to find the value, the minimum or the max for the equation y is equal to 4x squared plus 16x minus 3. So remember, that means you have to tell me if it's a min or a max. It's going to be one of the two, and you have to give me the coordinates of your vertex. Remember, it is a point, so it's in order to pair. And you find those by using x is equal to a negative b over 2a, and y is going to equal f of the x that you just found. So these 3 problems are due when you come to class tomorrow. So you have 3 problems due when you come to class, and that's going to be where we will pick up.